Hello guys. So welcome to Mac Out Smashers and also welcome to our exploration of the Internet of Things, a groundbreaking paradigm revolutionizing the connectivity of worldwide. In this video, we will delve into the intricacies of IoT, uncovering its vast potential to transform the industries and reshape the daily life. From the smart homes to industrial automation, IoT devices are seamlessly communicating, collecting data, and driving intelligent decision-making processes. So join us this journey as we unravel the transformative power of IoT. So at first we need to learn about the Internet of Things. It refers to a network of physical objects of things embedded with sensors, software and other technologies to connect and exchange data with other devices and systems over the network. In the field of computer science and engineering, IoT involves designing, developing and deploying the systems that enable communication and interaction between various devices and objects. These devices can range from simple household applications and wearable gadgets to complex industrial machinery and smart city infrastructure. IoT systems typically consist of sensors to gather data from the environment, actuators to perform actions based on the received data, and communication technologies such as Wi-Fi, Bluetooth or cellular networks to transmit data to centralized servers or other connected devices. The data collected by IoT devices can be analyzed and used to automate processes, make the informed decision, and improve efficiency and convenience in various domains including the healthcare, agriculture, transportation, and manufacturing and also home automation. Okay, so now it is time to discuss about the architecture and domains of IoT. The architecture of IoT involves the several layers such as each serving the specific functions to enable the communication, the processing and the management of data within the IoT systems. So at first, the perception layer. This layer comprises the physical devices or things embedded with sensors and actuators to collect data from the surrounding environment and interact with it. These devices can include the sensors for temperature, the humidity, the light, motion, GPS, etc., as well as the actuators for controlling the physical processes. Number 2. Network layer. The network layer facilitates the communication between the IoT devices and the internet or other networks. It includes protocols and technologies such as Wi-Fi, Bluetooth, Zigbee, RFID, NFC, cellular network, and more. This layer ensures the reliable data transmission and connectivity between the devices and the broader IoT ecosystem. The middleware layer. The middleware layer serves as an intermediary between the perception layer and the application layer. It handles the data processing, protocol transition, the device management and the other functions necessary to facilitate the communication and interoperability between the diverse IoT devices and applications. It also often includes the functionalities such as data filtering, the aggregation, and the security mechanisms. Number 4. The application layer. The application layer encompasses the software applications and services that utilize the data collected by IoT devices to provide the value-added functionalities and insights. This layer can include the various IoT applications tailored to specific domains or use cases such as smart home systems, the industrial home automation, the healthcare monitoring, or also environmental monitoring, transportation monitoring, and more. Okay, so now it is time to discuss about the domains of IoT. Okay, so at first, smart home. IoT devices are used to automate and control various home appliances and systems such as lighting, heating, the security cameras, the thermostats and the environment systems. The industrial IoT. In industrial setting, the IoT technology is employed to monitor and optimize the manufacturing processes, track inventory and perform the predictive maintenance and enhance the overall efficiency and productivity. The healthcare. The IoT devices are utilized for remote patient monitoring, the medical devices integration, medicine management, wearable health trackers and telemedicine services. In the smart cities, okay, so IoT technologies are deployed in urban environments to manage the traffic flow, They improve energy efficiency and monitor the air quality, optimize the waste management and enhance the public safety, and provides also the various other services to residents. Number 5, agriculture. In agriculture, IoT devices are used for precision farming, soil monitoring, crop management, livestock tracking, irrigation control, and other applications aimed at increasing agricultural productivity and sustainability. The retail. In the retail sector, the IoT technologies enable the inventory management and supply chain optimization, the personalized marketing, and customer behavior analysis, and seamless shopping experiences, both online and in physical stores. Okay, so now it is time to discuss about the IoT devices. IoT devices encompass the wide range of physical objects embedded with sensor, actuator, and connectivity features that enable them to collect and exchange data over the internet or other networks. These devices can vary significantly in terms of size, complexity, and functionalities, and they are utilized across various domains and industries. So here are some examples of IoT devices. At first, the smart home devices like the smart thermostats, smart lighting systems, smart locks and security cameras, and smart appliances like refrigerators, washing machines, voice control assistant like Amazon Echo, Google Home. Okay. So wearable devices like fitness trackers, smart watches, health monitoring devices like blood pressure monitor, glucose monitors. Okay. So industrial IoT like industrial sensor for monitoring the temperature, pressure and humidity, RFID like radio frequency identification tags for tracking inventory and assets, programmable logic controls PLC for controlling the manufacturing processes, connected machinery and equipment for predictive maintenance. Number 4, healthcare devices including the remote patient monitoring system, the medical implants and devices, pacemaker, insulin pumps, telemedicine equipment, smart pill dispensers. Okay, the smart city infrastructure like traffic monitoring, smart parking system, connected street lights. In agriculture, livestock tracking, automated irrigation system, the soil moisture sensors, etc. So these examples represent just a fraction of the wide array of IoT devices being developed and deployed across various industries and applications. As technology continues to advance, the capabilities and functionalities of IoT devices are expected to expand further, driving innovation and transforming numerous aspects of our daily lives and work environments. So now it is time to discuss about the Arduino, a popular platform used in IoT projects and prototyping. Arduino is an open source electronics platform based on easy to use hardware and software. It consists of a programmable microcontroller board and a development environment for writing and uploading code to the board. Arduino boards are designed to be versatile and accessible, making them suitable for a wide range of projects and including those in the IoT domain. So Arduino's architecture, like hardware platform. Arduino boards typically feature a microcontroller unit MCU, digital and analog input-output pins, and communication interfaces such as UART, SPI, 12C, and other components. These boards come in various form factors and configurations to suit different project requirements. The development environment. So Arduino provides an integrated development environment and that simplifies the process of writing, compiling, and uploading code to Arduino boards. The Arduino IDE is based on the processing programming language and provides a beginner-friendly interface for writing code. The IoT prototyping. Arduino boards can be used as a brain of IoT devices and projects. They can be interfaced with sensor, actuator, display communication modules such as Wi-Fi, Bluetooth, GSM, and other components to create the IoT solutions. Arduino's vast ecosystem of libraries and shields adds on boards further extends its capabilities, allowing developers to easily integrate and additional functionalities into their projects. And some educational tools. Arduino is widely used in education settings to teach electronics programming and IoT concepts. Its accessible nature and extensive online resources make it suitable for learning all ages and skill levels to explore the world of IoT and electronics. So overall, the Arduino plays a significant role in democratizing the IoT development by providing an affordable, user-friendly platform for creating the connected devices and exploring the possibilities of IoT. So, At the end of this video, as we conclude our journey into the boundless realm of the Internet of Things, we are left with profound applications of its transformative impact on our world. From the interconnected device in our homes to the vast network shaping the industries, the IoT continues to redefine the way we live and interact with technology. As we embrace the possibilities and challenges ahead, let us harness the power of IoT to create a more connected, efficient, and sustainable future for generations to come. So, thank you for joining us in the illuminating exploration of IoT. So, until we connect again, may innovation guide our path forward. So, thanks for watching. So, also like, share, and subscribe. If you have any queries, you can just comment down below, or we will also reply soon. Okay. So, goodbye.